Find a partial fractions decomposition for 4x over x plus 2 cubed. So we've got a linear term here, but it's being repeated 3 times. And so repeated linear factors cause us to introduce new terms and increase the power each time. Oops, it's a 2 there and a 3 there. There we go. So this is what our decomposition should look like. It's up to us to try and figure out the A, B, and the C now. Okay. And just to avoid confusion, let's make that 2 look a bit more 2-ish. Okay, multiply both sides by x plus 2 cubed. You got a 4x here. Now, x plus 2 cubed, 3 copies of x plus 2 will cancel out with 1 copy of x plus 2. Okay. You got 1 copy left over here. And x plus 2 cubed and x plus 2 cubed at the end with the c cancel each other out. Okay. So, what can we do? Well, we could solve for c pretty quickly. I'll let x equal -2. You'll get -8 over here, and then the a and the b, because they're being multiplied by at least 1 copy of x plus 2, will be multiplied by 0. And we see that c must be -8. Okay, well, what do we do for a and b? Well, unfortunately, there isn't a value that we can easily plug in to make everything work out. We could find different values of x, like x equals 0, x equals 1, some very nice simple things, and plug them in. And that's a great way to start things off. Okay. So we could try that. So if we say let x, well, 0 is probably the easiest one to start with, I would say. So we've got 4x, that's 0. It's a times, so it's x plus 2, 0 plus 2 squared, so 4a, 2b. I could write in c, but I know what c is. It's -8. So what does this tell us? 8 is 4a plus 2b. I suppose we could divide by 2 and say 4 is 2a plus b. But this doesn't let me solve for a or b individually. But we could get another expression, like x equals 1. So 4 times x is 4. Okay. We get x plus 1, so x plus 2. 1 plus 2, so that's 3 squared, so that's 9a plus 3b, and again, c is -8. So 12 is 9a plus 3b. Okay, divide by 3 on both sides. We got 4 is 3a plus b. Now that's kind of interesting, because I thought 4 was equal to 2a plus b. So once you get to a stage like this, you can just sort of work around with the equations. I got lucky, they're both equal to 4, so we can set them equal to one another. And we can say, well, the b's cancel out, so 2a is equal to 3a. Well, that means if you subtract 2a from both sides, you get 0 is equal to a. And once I know 0 is equal to a, that must mean b is equal to 4. So there we go. Now, that's not the only way to do this. Here's another way to do it. I'll show it off briefly. One of the nice things about polynomials, and really there's just so many things about polynomials to love and adore, is that their coefficients are unique. So if you've got 2 polynomials that are equal, then their constants have to be equal. The coefficient of the x's have to be equal. We've got 2 polynomials here. So if you're brave enough, you can expand this out. X squared plus 4x plus 4. Bx plus 2b plus c. I'm going to stop with the c. I'm going to just write -8. Okay. We'll even bring it over to the other side. So 4x plus 8 is, let's see, ax squared plus 4ax plus 4a. Plus bx plus 2b, and if we start collecting constants, we'll see we've got 4a x's, and then we've got b x's, so 4a plus b copies of x. And we've got 4a plus 2b for our constants. Okay? But as I say, polynomials are only equal if their coefficients are equal. So that means they're the same number of x squareds over here as over here. Uh-oh. There aren't any x squareds. That's a quick way to see that a should be 0. Once we do that, well, 4a is just 0. We'll get bx plus 2b. 4x's should be the same as bx's, and that's another way to see that b is equal to 4. So either way we do it, or if we come up with another way, we get a is 0, b is 4, c is negative 8. And we're all set with our decomposition. So we can even just draw, you can write it in if you want to, 0 over x plus 2, but you can also just drop it, I suppose. Doesn't really matter. So b was 4, and that was over the x plus 2 squareds. And then I suppose we could write minus 8 over x plus 2, or you could write plus negative 8 and really show off the coefficient you learned. But there we go. Our partial fractions all done.